So, this is Lesson 3, Module 5 of 8th grade Engage New York. I'm going to keep saying this because that's what we're doing now. I don't get to name the lessons anymore. Right, Ryan? Ryan, be happy, man. It's a happy Monday. It's a short Monday. Are you not happy? Would a purple sticky note make you happy? What if I drew a smiley face on it? Ryan. I'm trying, man. I don't know what to do for you. What if I put a purple sticky note like on my shirt with a smiley face? So every time you saw it, you'd be like, wow, look how happy Mr. H is. Yeah, smile, winning. Okay. So here's my question. Is it a function, why or why not? Every single one of us got number 1. So is it a function, why or why not? Ellie, is it a function?
Yes, it is a function.
I love that answer so far. So let's just stop there. Thumbs up if we got yes. Okay, Ellie, tell me why.
It's a function because each input value has a different output value.
I love it. Okay? I wouldn't have even gone that mathematical. Ellie told me each input has its own and exact output value. Input being our x's, outputs being our y. I mean, that is beyond what I would expect for this answer. That is, to the book, perfection. Each input has its own output. What do I say to make it easier for everybody? All x values are different. But I like Ellie's better. Okay? So you need to have something written down next to number 1 of yes, because why? Ellie said all the inputs have their own exact output values. All that is a little bit dumber down so I can understand it. All x values are different. We can't have 8 bags of candy costing $10 and 8 bags of candy costing $12. That doesn't make it a function. Okay? Each input has its own output. Very good, Ellie. Questions on, is it a function? Okay. Now, this is where it gets a little bit tricky. It makes you have to go back and look back at lesson 1. What do we do to find if it has a constant? Are we adding? Are we subtracting? Are we multiplying? Are we dividing? Now, I'm going to ask for a couple different things. Emily, usually your hand shoots right up. And it didn't this time. She's like, oh, man. Emily, you came up to me and you said, here's how I found if it had a constant. What did you do to find out that it had a constant?
Well, I looked at 1 and 2500, and then I looked at 2, and I noticed that to get to 25 to 50, you have to add 25, and to get to 22, you had to add 1. So then I looked at
Can we stop there? So what I'm hearing you saying is, to get from this to this next set, you added 1 and 2500s.
Yeah.
Okay, how about to get from 2 and 5000s to 3 and 7500s?
You had to add something.
What is what?
1, 20, 2, 500.
So what you're telling me is each time you added 1 and 2500ths. Does everybody see that? That's correct. Here's my question. What if I, and I'm not going to write this, what if I draw and put 30 bags of candy? Would you want to add 1 and 2500ths for 9, 10, 11, 12, 13, 14, 15, all the way up to 30 to figure out how much it is? Me either. So how else? So there is nothing wrong with how Emily did it. She was able to look at it and say, there's a pattern. I'm adding 1 and 2500ths every time. It's staying the same, which means it's staying constant. How did I have you figuring out how to find that constant? Was it addition? Was it subtraction? Was it multiplication? Was it division? Division. What were we dividing? Yeah. To figure out if we have a constant, we had to do y divided by x. I would absolutely have this somewhere with number 2. Y divided by x. That's how we're finding whether it's a constant. So we can say y divided by x is equal to 1 and 2500ths divided by 1, 2 and 5000ths divided by 2, 3 and 7500ths divided by 3, and so on and so on and so on. Everybody still with me there? Okay?
Oh, sorry.
Ellie, can you go touch the mouse for me on my computer? And shut off for some reason. Okay? So does it have a constant? Now that we've done this, are each of these division problems the same? Come on, guys, I need something. Are the division problems the same? Are we going to get the same answer right?
No.
Yes? You're saying yes? Okay, what do we get for the constant? Y divided by x is what? You have a calculator in front of you.
The constant answer was 1.25.
It was 1 and 2500ths. Do that right. So take 3 and 7500ths divided by 3. Tell me what you get.
Use the calculator.
He is.
Okay.
He's got it, finally. Good. Do 10 divided by 8. Tell me what you get. Okay. We need to do this in order to find the constant. You should have all of this written down so far. Now we're going back to last Thursday. The last question I asked you is, if it has a constant, write an equation. Well, what type of equation is it going to be if we have a constant? What would our graph look like? That's the better question. What would our graph look like if there is a constant? Emily? It would be a straight line. If it's a straight line, what do we call that? It starts with an L. Megan? A linear equation. So we know linear equations are in the form of y equals mx plus b. Where will our constant go? Which letter does our constant take the place of? So go back to lesson 1. Okay, you should still have those notes out. Go ahead, Sam, which one?
No, I was going to ask. I need to make sure that I know what a constant is.
Okay.
I need to make sure I didn't misunderstand.
Okay, go ahead.
What is it?
It's y divided by x. It's the difference between y and x.
So what happens? By y and x, that's what it is.
Yes, sir. As long as it stays the same, constant. So which variable does our constant go in the place for? Reagan? Is it y, is it m, is it x, is it b? Where does it go in for? To write our equation. Take a guess. It's all right if you're wrong. Which letter? Just guess one of the letters, it's fine. Y, okay. So we know that it's not y because we're taking y divided by x to get an answer. So we can take away y is not one of them. We can take away x is not one of them. Which one is going to be our constant then? M or b? What do you think, Cole? M. Our slope, our rise over run, is our constant. That's how we get our linear equation. So our equation, we take the constant and we place it in for m. So the equation for this graph, or for this function, is y equals 1 and 2500ths x. Okay? So here's why we use this. Here's why it's important that we get an equation. Let's go back to my question that I posed to Emily. I said, Emily, do you want to add 1 and 2500ths all the way to 30 bags of candy? Did you want to do that? No, I don't want to add 1 and 2500ths, another 1 and 2500ths, and so on and so forth. But let's say x equals 30. So I'm now looking up here. My bags of candy are which variable? My bags of candy are which variable, Cameron? Bags of candy are x. So if x is 30, that's how many bags of candy I have. Can I find the cost? Yeah, because we know each bag is $1.25. So get your calculators. You can do y equals 1 and 2500ths times 30. So we could figure out when x is 30, what does y have to be? Madison, what'd you end up with?
37.5.
So 37.50, because if this is cost in dollars, it's $37.50. we make an equation so that we can substitute things in that we do not know. If it's linear, if it's staying constant, we will know how much 30 bags of candy costs. Everybody with me? Okay. How would I describe this in words? How would I describe the function that's happening in words? And what I mean is, can you tell me how much per bag? That's what I'm asking. Can you describe in words how to talk this function through?
Talk to the people at your table. If you had to answer Mr. H's question, what words would you use to answer the question? Ask it again, please.
So I'd like you to use words, not anything else up there, but use words to describe what's happening in this function. So if you had to write a sentence, how would you describe what's happening on the board? So this is where you're going to talk with your group. Go. That was great, Sam. Sorry.
So, I had to just say, look, I'm looking at this, and I know this information about that and cost dollars. What would you, in general, say about that? How are they related?
Does my back group back here have an answer?
So who needs 30 bags of candy?
Gentlemen, Ryan, I'm going to remove your seat buddy if you cannot behave there.
How would you answer that question? I need a budget, how much I need for this many bags. You need to give me some information so I can do that.
Okay, Lydia, can you tell me in words how you would describe this function?
For every bag of candy, the cost increases by
Yeah. So I love how she said that. She goes, for every bag of candy, the cost increases by $1.25. That's great. I could even make it a little bit simpler, because right now, this $10 for 8 bags is a rate. A rate is a number divided by another number that is not 1. Unit rate is when we're dividing by 1. So the unit rate for this function is $1.25 per 1 bag of candy. If I asked for a rate, you could use $6.25 per 5 bags of candy. Rate and constant are different terms. So I love what Lydia said. Again, she said for every bag, the cost increases $1.25. Everybody with me? Chase, question for you. What would be my cost if I have 0 bags? Huh? $0. So if I have 0 bags and $0, does Lydia's words still work? If I add a bag of candy, does it still go up $1.25? Yeah, because I could put 0, 0 here. If we add a bag, the cost goes up $1.25. That's how we're using our words to explain it. Yes, Sam?
So no matter how much money you start with, it's always $1.25 for every one bag of candy.
Yes. Very good. Questions here? Okay.
Yeah, who needs that much candy?
I don't know. Probably Halloween. I'd use it for Halloween. So here's what I'd like you to do. Go to, so you're on that front, flip it all the way over. You're now on a page that says example 5 and exercise 1-3. Okay, so you're now on a page that says example, and I'm going to pull it up. It says exercise, so at the top it says example 5. I want you to go where it says exercises 1 through 3. Okay, let's take a look just at that right now. So we're going to be doing a little bit of work here. The first thing says, Hannah claims she mows lawns at a constant rate. So what would be the key word there? Sam?
Constant.
Constant. We should all know how to find the constant. So what I would do next to it is I would write something that I'm going to be able to use for a constant. So a letter and another letter. So I'd be using two letters next to there so that I'm going to be able to find a constant. So letter A says, is the data presented consistent with the claim that the area mode is linear function of time? That means if it's linear, what does it have to have? A constant. So for it to be presented consistent with the claim, we should be finding what? The constant. So listen, what you are doing right now is you are going to do A through G. So you are doing points A through G. I would love to go over this before we leave because we have a little bit more time in this class. If you look at the time for second hour, we only had 28 minutes. But for fifth hour, I've got 48 minutes. We should be able to go over this before you leave, and you should have no homework. So you need to work on A through G. But flip the page. Go to letter C. I think it's letter C. It says, at what rate? Does it say unit rate? No. So a rate, does it have to have a denominator of 1? Do we need to divide? Nope. Okay, go. So you're doing A through G. Go ahead. Yeah. Came over there. Yes, ma'am. This is group. This is still group. Anytime that we're giving you something in class, it is now always group. You can talk all the time until a test. So homework is exercise 1 about Hannah, A through G.